Thank you. Yes, I'm Barry Aitken. I'm really delighted to be a part of the Dynamo20 conference and to have the chance to deliver this closing plenary session. Over the course of today, we've had discussions about many different industries and many different areas of digital innovation. Everything from fintech to health research, education, cybersecurity, construction, so many different areas which have really highlighted the tremendous opportunities around digital innovation and new digital industries, opportunities to bring incredible benefits for the economy and also benefits for wider society. But what I think has also been abundantly clear throughout today's discussions is that along with these tremendous opportunities, there are also some very real challenges associated with digital innovation and emerging digital industries. Some of those challenges are practical or technical, but many of those challenges are ethical. There are questions that raise questions not just of what we can do, not just what we can do in terms of new digital skills or digital capacities, or what can we do with the new data capacities that we have, but more importantly, what should we do and what should we not do? And those are really, really tricky questions. Those are not questions that we have straightforward answers to. But I have some very good news, because in this final session of the Dynamo20 conference, I have the answer. I have the answer for all these tricky questions, all the ethical dilemmas that you might be facing. Because no matter what area of digital innovation you work in or what kind of industry you work in, whether you're developing machine learning programs, whether you're doing research, whether you're in product development, whatever role you have or whatever interest you have in digital innovation, there is one answer to every challenge you face. And it might surprise you, because the answer is kangaroos. Not what you're expecting? Well, over the next half an hour or so, I'm hoping to explain that to you and to convince you all that no matter what role you have in relation to digital innovation or what your interests are in relation to digital innovation, you need to watch out for kangaroos. And I promise that will become much more clear very soon. But before we get into that, I want to give a bit of background to who I am and my interest and why I'm such a passionate advocate in the power of kangaroos in digital innovation. Yes, as I said, I'm Barry Aitken. I'm a Senior Research Associate at Newcastle University and the Newcastle University Business School. And in my research, I'm interested in ethical and social dimensions of digital innovation, particularly relating to artificial intelligence and machine learning and to big data analytics. And I'm really interested in the impacts that digital innovation is having on our lives as individuals, as well as on our society more broadly. Because really digital innovation is transforming our society, particularly innovation around artificial intelligence and big data analytics is having some really quite profound impacts on our society, as well as on our lives as individuals. So the title of my talk today is Blame It on the Algorithm. And I'm going to give a series of examples of things that you can blame on algorithms. And through these examples, I want to highlight some of the kind of ethical dilemmas and ethical considerations that we need to take into account when we're thinking about digital innovation and the role digital innovation plays in our lives and in society. So the examples I'm going to present are examples of algorithm decision making, and of artificial intelligence. And I'm going to explain how these are things that you can blame on algorithms and what that means. So what do we really want to blame things on algorithms? So I have here a series of cards. These are my cards of algorithmic decision making, which are fairly random. Each card has an image of something that you can blame on an algorithm. When I turn the card over, I'll give you a moment to try and figure out what that might be and how it might relate to algorithms, and then I will explain. And we'll see where it goes from there. So the first card I'm about to reveal, it is a pig. But it's not just any pig. Very importantly, this is a happy pig. And this card relates to a facial recognition program. Now, there's some research that's been conducted in Edinburgh by researchers who have been training a machine learning program, a facial recognition program, to detect the emotional well-being of pigs. It's wonderful, isn't it? And so this facial recognition program has been trained to detect the emotional state of pigs. And with the intention that this could be used in the future on pig farms. Now, I should be clear, I'm not talking about quaint kind of children's storybook backyard pig farms. I'm talking about industrial scale pig farms. pig farms where there may be hundreds or thousands of pigs, and the farmer or farm workers aren't able to kind of regularly on a daily basis keep an eye on the well-being of those pigs. So in those conditions, many pigs may be developing a health condition, may be becoming unwell, and it's not detected until it becomes very serious, until the pig needs expensive veterinary treatment, or perhaps no more pig. So the idea is to train a facial recognition program which can look at the pig's faces and detect when they are becoming perhaps a less than happy pig. How do they do this? As with many machine learning programs, it's trained on data, on images. So they train this machine learning program by showing it images of pigs, showing it images of happy pigs, and images of pigs that are less than happy. Now, I know this is going to be a bit more complex than this in reality, but with labels saying happy pig, not happy pig. Eventually, the machine learning program, through looking at lots of images of these happy pigs and less than happy pigs, can begin to recognise what makes a happy pig and what makes a less than happy pig. So that then, if it's shown a new image of a pig, it can decide whether that is a happy pig or a not happy pig. And then eventually this can be put into a facial recognition camera, which can be used in these pig farms to scan the faces of the pigs and detect when a pig might be becoming unwell, might be becoming not a happy pig. And I really like this example because facial recognition is very topical. We hear about facial recognition increasingly often in the news and in the media, and it's pretty controversial. Often when we hear about facial recognition, it's in terms of, say, scanning crowds in public places to identify individuals to be stopped by the police. It's also being used in advertising, in billboards, in scanning people's reactions to billboards and advertising, making some assumptions about gender, ethnicity, age, and using that for marketing purposes to understand people's reactions. It's also being used at pop concerts, so for example Taylor Swift concerts, being used to scan the faces looking at billboards, looking at interactive screens, and to identify if there are any known stalkers within that crowd. So facial recognition has been used for lots of different purposes, and many of those purposes are quite controversial. They raise a lot of issues around privacy, around the extent to which we consent to our data being collected and to our faces being scanned in these ways. But I like this example because I kind of think the pigs probably don't mind too much. Like, they probably aren't too worried about privacy and informed consent. They've kind of got more life and death things to be thinking about. But at the same time, the more I think about it, I do start to wonder if, well, is this an example of technology being used to deal with the symptoms of the problem rather than the problem itself? Like, couldn't we maybe do something to actually improve the conditions of those pigs' living conditions so that it is possible to recognise that they're becoming unwell before it reaches that point? And do we need to have a technology to deal with the symptoms rather than the problem itself? That's perhaps an analogy that we could think about in other contexts. But before I get too much into pig welfare, let's move on to the next card. And it's this one. It is, I should say quickly before anybody gets the wrong idea, handcuffs, yes, it's policing. Let's be clear. Yeah, this example relates to policing because algorithms are increasingly being used in policing and law enforcement. There's a number of predictive policing algorithms that are currently being used. And these are algorithms that are used to predict where crime might occur, or in some cases, who might be the victims of crime. And so there's a number of different predictive policing algorithms currently available. The most well-known one is Predpol. Now, Predpol was an algorithm which was developed in the US, but it's now a commercial product and it's used by law enforcement departments around the world, including here in the UK. So the predictive policing algorithms work by looking at historic policing data, so data about where crimes have been detected, where arrests have been made, and using that data to model and predict where crime is likely to occur in the future. So these predictive policing algorithms are used by police forces to predict where crime is likely to occur so that they can allocate resources and increase efficiency of policing by knowing where they should send forces at the right time in the right place. Now, where this has been trialled, there have been very positive reports, evaluations of these predictive policing systems. They're said to increase efficiency, to enable efficient allocation of policing resources. But of course, there's some fairly problematic dimensions of this as well. As with all of these algorithms, they're based on historic data. And of course, if you're making decisions about where crime is likely to be found in the future based on data of where you found it in the past, quickly you can get into a bit of a vicious cycle where if an area has been over-policed in the past, or a community has been over-policed in the past, you're going to have more data to suggest that that's an area or a community which needs to be more policed in the future. So quickly you can get into a vicious cycle where if you have more data about crimes occurring in an area, you're more likely to look for crime in that area and therefore more likely to find crime in that area. And studies which have really looked at the impacts of predictive policing in different communities have often found that they tend to focus primarily on marginalised communities, and certainly in the US, in black communities and ethnic minority communities. And of course that's because of the existing prejudices within the system and with the data that are feeding into these systems. So there are really important ethical dilemmas around the accuracy of the data and the biases within the data that is being used. But there's also ethical dilemmas around the kind of decisions about what we're using these algorithms for in the first place. So not just the accuracy of the data or the prejudices in the data, but actually the biases and values that are shaping decisions about how we use those systems in the first place. So to make that point clearly, a few years ago, there was a data scientist in the US who decided to develop a predictive policing algorithm. Now, these predictive policing algorithms typically are used for, say, street crime, gang-related violence. And this data scientist in the US decided to show some of the injustices that are present in current systems by developing a different kind of predictive policing algorithm, one that would look at white-collar crime. And so they followed the same kind of approaches, the same kind of methods that are typically used in these predictive policing algorithms. They use the same kind of data science methods. They use existing data about white-collar crime had been detected, where arrests have been made, and data about convicted criminals. And they created a map that could predict where white-collar crime was most likely to occur in the future. They took it quite far. They made an app that you could download onto your phone. It would give you a map where you could be walking around, and it would let you know if you were, whoa, watch out, walking into an area of white-collar crime, be on guard. And of course, this, you won't be surprised to hear, that this map had quite a lot of hotspots in fairly affluent areas, a lot of hotspots in Manhattan, for example. So the data science went one step further. They had this app where you could locate white-collar crime hotspots, but they went one step further and they created an image of what you might expect a white-collar criminal to look like. Now, obviously, this is a bit of a controversial one, but it has been proposed in other areas in the past. So there have been proposals to create images to predict what a gang member might look like or what a street criminal might look like. And as you can imagine, there are quite a lot of prejudices and biases that go into that. So in this instance, they looked at images of convicted white-collar criminals and they put these into a program which then generated a kind of generic image of what you might expect a white-collar criminal to look like. And you may not be surprised to hear that the image that was created was of a fairly generic, middle-aged white man. And a lot of middle-aged white men were really upset about this. And people started to say, like, how dare you? How dare you make assumptions about what I might do in the future based solely on what other people who you consider to be like me did in the past? Which is kind of the whole point, because that's what's been happening in lots of areas for a long time. It's just it's not been middle-aged white men that it's been happening to. And I think that makes the point really clearly that we need to be really careful about the kinds of values and assumptions that are shaping decisions about where we use new technologies. It's not just about the accuracy of the data or ensuring that the data that we use is bias-free, if that's ever possible, but actually thinking about the kinds of decisions and the kinds of values that are shaping decisions about where we invest in digital technology, what kinds of technology, in what kinds of circumstances and for what kinds of purposes, and what do those decisions reveal about our own biases and our own assumptions. So, time to move on to the next example, which is Harry Potter. Did you know that you can blame Harry Potter on an algorithm? Well, not the whole of Harry Potter, but this one limited edition book, which is Harry Potter and the Portrait of What Looked Like a Large Pile of Ash, which is fascinating, isn't it? So admittedly, this isn't written by J.K. Rowling, it's written by a bot. So it's written by a bot, Botnik. Botnik is a website anybody can go onto. You can input text of pretty much anything you want, and it will create a kind of predictive text keyboard which can create new text in the style of whatever it was that was inputted. So people have done it with all kinds of things. You can create a text in the style of Michael Jackson and in the style of the Bee Gees. People have done it with Donald Trump speeches. So they tortured this poor bot with inputting Donald Trump speeches, real Donald Trump speeches, and it then created an algorithm which could produce speeches in the style of Donald Trump. And it's amazing because when you read them, they pretty much make no sense, but they really sound like Donald Trump. It's great. And people have also done it with Harry Potter. So they've inputted text from Harry Potter books to then create an algorithmically produced Harry Potter book. And I'll read you a bit of an excerpt because it really is something. So here's Harry Potter and the portrait of what looked like a large pile of ash. Harry could tell that Voldemort was standing right behind him. He felt a great overreaction. Harry tore his eyes from his head and threw them into the forest. Voldemort raised his eyebrows at Harry, who could not see anything at the moment. The tall Death Eater was wearing a t-shirt that said, "Hermione has forgotten how to dance." So Hermione dipped his face in mud. That's brilliant, isn't it? I mean, I'm not a big Harry Potter fan, but I do think that might be the best book. But what I think this example shows us is, this is something fun. Okay, so this is a website that anybody can go on, you can play around with, and you can create text and all kinds of stuff. And it's a bit of fun. Okay, it doesn't really matter too much. It's a bit of parody, it's a bit of comedy, it's kind of light relief. But what the example also shows us is the potential for what does this mean for the future? We often think about the risks of automation in terms of jobs or in terms of human endeavour, like the risks for unemployment from greater automation in the workforce. We tend to think about that in terms of, say, manual jobs or in terms of jobs which involve a lot of processing of information, things where the gain is really about increasing efficiency. We tend not to think about automation so much as a risk in more creative jobs or intellectual jobs. But I think what this example shows is that while this is not quite there yet, it's moving in that direction, and it raises questions about what does it mean, what does creativity require, or what is the role of the human within that, and how much of that can be replaced by machines, and what are the implications of that. There's also some real risks that these kinds of automated processes could be used to say, generate fake legal documents, by creating documents which are entirely fake but are very plausible because they're created in realistic legal language and legal text. It can also be used in generating fake news, and particularly in social media and online news content. And it's very topical at the moment, but it raises really important questions about what is the role of this and what are the potential implications of greater automation? Where does this lead to? What are the potential slippery slopes around that? So, bye-bye Harry Potter. And the next card is, it's this one. El Serenata del Amor. Very romantic. This example comes from Brazil. El Serenata del Amor is the Serenade of Love. It's a beautiful love story, and it centres around a main character by the name of Rosie. But from that point on, it's a lot less romantic, because Rosie is in fact a bot. She's an algorithm. Rosie is a bot which is used in Brazil to process publicly available data about expense claims of elected officials. So MPs' expense claims, we all remember them, right? So Rosie processes this publicly available data to identify potential anomalies or potentially fraudulent claims, fraudulent expense claims of elected officials. I love this example because what it shows us is this is really a citizen-led AI project, a citizen-led development of an algorithm. A citizen-led project which is using publicly available data to hold elected officials to account. I think that's brilliant. I also think it's brilliant because often in many of the examples that we have of, say, controversial data practices or uses of AI which have raised ethical concerns, it's often examples where that data is being controlled by either big multinational companies or by governments, and there are issues around ownership of data and access and control and the implications for citizen involvement or citizen empowerment or disempowerment. But in this example, this is an example of a citizen-led initiative where citizens themselves have decided to use this data to hold elected officials to account, really for a public good, for societal good. I think that's brilliant, and I think that's where there's a real possibility, and I'm really excited about the opportunities for more citizen engagement and citizen involvement in really using data and using digital innovation for public benefit and public good. That's what gets me excited anyway. So the next card is evil. It is evil. Did you know you can blame evil on an algorithm? You can. Well, specifically algorithms by Google algorithms. Let me substantiate that statement very carefully. So, for a long time, Google have had a code of conduct. A code of conduct that sets the ethos of the company, guides Google employees. And for years, in that code of conduct, they had this kind of mantra. This mantra that was, don't be evil. That's wonderful, isn't it? I mean, I think essentially that takes kind of all the key messages of the world's main religions and distills it down into one easily digestible core message. Don't be evil. It's beautiful. But early in 2018, there was a bit of controversy around Google, as there often is. But in this instance, it centered on something called Project Maven. So Project Maven was a project where Google were collaborating with the Pentagon in the US. And they were looking at images from drones. So these are military drones that are being used to drop bombs in distant locations. And currently, the images from those drones are monitored by human military operatives at a large distance who look at those images from drones and decide whether or not to drop bombs in distant locations. And so Google were looking at these images from these drones and looking at past human decisions about whether or not to drop bombs to potentially, and I stress potentially, but potentially in the not too distant future, automate those decisions. Create a machine learning program which could automate decisions about whether or not to drop bombs. Fundamentally, life and death decisions. Now, there was a bit of controversy for a number of reasons, but some people started to say that maybe, just maybe, there's a bit of a discrepancy between not being evil and training computers to kill people. It was a bit of a tricky one, and Google clearly agonised over it. A lot of Google employees left the company or threatened to leave the company as a result of this. It was very controversial. But eventually, Google put their hands up and they said, you know what? Yeah, there is a bit of a discrepancy there. There's a bit of a tension, but we're going to do the right thing. And they put their hands up and they dropped "Don't be evil" from their code of conduct, which is true story. I kind of think for Google employees that must have just been such a liberating moment. I mean, the possibilities that opened up really would have been tremendous. But what also is really interesting about it is they dropped "Don't be evil," but they kept "Do the right thing," which I think raises some really interesting philosophical questions around just how much evil is okay to do the right thing. Something to discuss later. And obviously that's a very light-hearted take on a very serious ethical dilemma with very serious potential implications further down the line. But I think it really does raise some pretty big concerns around the potential future roles of digital innovation and artificial intelligence, and where do we draw the line? Because while that example might seem, I think, to most people pretty controversial, pretty uncomfortable, but how many steps back from that are we at the moment? And where is the line that we draw? What are the things that can be automated? What are the things that can't be automated? Where do we need human judgment? And where do we draw the line? And I think those are big, big questions to ask and consider in all the areas that we work in. So we have one final card, and it's the moment you've been waiting for, because it is a kangaroo. I promised you, I was going to convince you that you need to watch out for kangaroos. Whatever area of digital innovation you're working in, whatever industry you're working in, you need to watch out for kangaroos. I promised you I was going to tell you that kangaroos are the answer to all your problems, to all the challenges you face, whether they're technical, ethical, thinking about social implications. Watch out for kangaroos. Here we go. So in this example, it relates to autonomous vehicles, self-driving cars. And it's a story about Volvo. So a few years ago, Volvo were developing an autonomous vehicle, a self-driving car. This autonomous vehicle has artificial intelligence to allow the car to make decisions, to know how to operate. So the car was being trained to do lots of different things. It was trained to read road signs, to know how to behave out on the roads. It had to learn to, say, recognise if a person walked out into the road, to know to stop. It also had to learn to recognise if an animal stepped out into the road and to know to stop. And this car, this Volvo, was doing very well. It was doing very well in road tests in Sweden. It had been taught to do all kinds of things, and it was functioning very well in road tests in Sweden. Volvo took the same car down to Australia to run some further tests, and it failed spectacularly. Because while it was very good at recognising if an elk stepped out into the road or a moose stepped out into the road, it had no clue what to do when a kangaroo came hopping along the road. And I mean, okay, so fair play to the algorithm, because kangaroos are pretty weird animals. I recently had a road trip in Australia and I can confirm they are confusing. But yeah, I think what this example shows us very clearly is that the context in which an algorithm is developed is really important for how it functions. So when algorithms are being developed, when artificial intelligence programs are being developed, there are certain assumptions that are programmed into those algorithms. So assumptions about what they need to know to operate properly out in the world. And those assumptions reflect the values and the positions or the prejudices of the individuals and organisations who are developing those programs. So had this self-driving car been developed in Australia, they probably would have thought to teach it about kangaroos much sooner, and perhaps it wouldn't have been so good at recognising moose or elk. And that's an analogy that can be applied to, I think, all the examples that we've discussed today, and all the areas of digital innovation that you may be working in. Who are the kangaroos that we need to take into account? Often the kinds of ethical dilemmas that arise in relation to digital innovation arise because vulnerable groups or disadvantaged groups, minority groups' views haven't been taken into consideration in the development and planning processes of whatever those products or outcomes might be. So often a new digital product or a new service or an artificial intelligence is out in the real world, and then people say, well, you know what, if you'd asked us, we could have told you that would have happened. So the problem is that many ethical dilemmas and many risks or negative outcomes occur because we haven't anticipated or thought about how those innovations or developments impact on different groups within society until it actually happens, and then we have to work back from there. So we need not just to watch out for kangaroos, but actually we need to get kangaroos developing algorithms. We need to get kangaroos involved in all the processes of digital innovation and all the digital industries to ensure that everybody's interests are included and are reflected. And we've seen this very clearly in a number of different areas where there have been ethical dilemmas around digital innovation, particularly artificial intelligence, say facial recognition. We know that facial recognition works incredibly well if you happen to be a white man, much less so if you have a darker skin tone or if you're a woman. And that has really important implications for people's lives and also for society. When we're relying on these technologies for policing, for all kinds of things which affect people's access to public spaces, people's enjoyment of public spaces, and they have different outcomes for different groups. And so we need to involve kangaroos, we need to identify who those kangaroos and get them involved in those processes so we can anticipate what the potential outcomes might be for everybody in society and not just the privileged groups who happen to be developing and being involved in the processes of digital innovation. So that's it. If there is a takeaway message from this talk, from this conference, let it be, watch out for kangaroos, but also let's get kangaroos involved in digital innovation. There we go. Thank you. It's been a real delight to deliver this plenary session. I'd love to know what you thought. Look me up on Twitter. I'm quite easy to find, Barry_Aitken. Yeah, I'd love to hear your questions, your comments. I'd love to know who the kangaroos are in your area of work and what you're doing to engage more kangaroos in digital innovation. Thank you.